Hello, we will be working on target 6 and 7 homework today. If you have not watched the notes yet too, please make sure you do watch those if you were not in class. Target 6 about is determining if something is a solution to a system of inequalities. So on 1 and 2, we gave you the inequalities. Remember, to be a solution, that point has to be true in both inequalities. When I plug -2, 1 in, remember -2 is my x, 1 is my y. So I get 1 is greater than or equal to -2 minus 6. -2 minus 6 is -8, and 1 is greater than or equal to -8. If it works in the first inequality, remember you have to check the second inequality. So we'd have 1 is less than -2 times -2 plus 8. -2 times -2 is a +4. +4 plus 8 is 12, and 1 is less than 12. So -2, 1, the point is a solution. Number 2, we're going to plug in -2, -5. So I'll plug -5 in for my y. -5 is less than or equal to the negative of -2 plus 4. Be careful with the two negatives there. You're plugging in -2 for x, so you still have that negative in front of it. The negative of -2 is a +2, so -5 is less than or equal to 2 plus 4, so -5 is less than or equal to 6. That is true. Again, we need to try it in our second inequality. In our second inequality, if -5 is greater than -2 minus 1. -5 is then greater than -3. That is not true because -5 is less than -3. So -2, -5 is not a solution. When we look at graphs to determine if an ordered pair is a solution, remember you want to graph that point and see if it is in the area shaded by both graphs. If we have 3 points, we need to have 3 answers. So my first point is 4, 0. When I graph 4, 0, 4 for my x, 0 for my y, that is not in the area shaded by anything, so it is definitely not a solution. When I graph the point 0, 4, 0, 4 is in the shading of the blue graph, but it is not in the shading of my red graph. So 0, 4 is also not a solution. 0, 0, when we graph 0, 0, it's right at the origin. It is in the shading of the blue and the red graphs, so it is a solution. Number 4, 0, -5. So looking at a y on the y-axis there. 0, -5 is on a dashed line. Remember, anytime you are on a dashed line, it cannot be a solution. If that was a solid line, we would have a solution because it is shaded by the red area. 0, 0, 0, 0 is only shaded by my red graph and not by my blue graph, so it is not a solution. And 4, 0, 4 for your x, 0 for your y, is shaded by both the red and the blue, so 4, 0 is a solution. Target number 7, we switch from checking if something is a solution to actually graphing these on our coordinate plane. Remember, we graph them just like an equation. We just have to remember our dashed lines if it's not an equal to symbol, or our solid lines if it is an equal to symbol, and then we also need to remember to shade. On number 1, we always start with our y-intercept. So here +2, or my b value in slope intercept form, is my y-intercept. My slope is then -2. Remember, if we have a whole number, we always put it over 1. So from my y-intercept, I'll go down 2 to the right 1, down 2 to the right 1, or you could have chosen to go up 2 and to the left 1. My inequality symbol does not have an equal to sign, so that tells me that I need to connect the points with a dashed line. When I go to shade, you can plug in a test point. Here 0, 0 would work as a test point because it is not on that line. Or you can read the inequality. Y is less than -2x plus 2. So I'm going to shade in everything that is less than it. For the second inequality then, we have y is less than or equal to 3. Here my slope is 0 because I do not have an x, and my y-intercept is going to be positive 3. So remember, we have a y equals equation. That's always going to be your horizontal line. This is equal to because it has the less than or equal to symbol. So I will graph it with a solid line. It asks for everything less than or equal to 3. So we're going to shade everything below this graph to get y less than or equal to 3. On number 2, again, we will start by graphing our y-intercept. My y-intercept is at -2. My slope's a -1/3. So remember, that means down 1, right 3. Or we can go up 1, left 3. I have the equal to symbol in my inequality, so I'm going to connect that with a solid line. That is not a solid line. Sorry about that. So we're connecting with our solid line. It wants everything greater than or equal to for our y values, so I'm going to shade everything above the line. For my second graph, I have a y-intercept of 1, and I have a slope of 2 over 1. So from there we need to go up 2, right 1, up 2, right 1. Or you can go down 2, left 1. We have an equal to symbol, so we need our solid line again. And then it wants everything less than or equal to. So less than is going to be underneath our graph. So to go underneath our graph, I'm going to shade everything on this right-hand side. Number 3, we have 2 more inequalities to graph. So we'll start with our y-intercept of -3. I have a slope of 4/3, so we go up 4, right 3, up 4, right 3. It does not have an equal to symbol, so this time I will use that dashed line. And then I need to shade. I want everything less than again, so I'll do everything underneath that graph. For our second graph, I have a y-intercept of +6 and a slope of -1/2. So down 1, right 2, or up 1, left 2. We again don't have an equal to symbol, so we're going to have to use another dashed line to connect these. And it wants us to shade everything less than also. So again, less than is always going to be below that line. So I'm going to shade everything below my blue line. For the last problem, our y-intercept is up at a +6. The slope of -3/5, so down 3, right 5, down 3, right 5. It has the equal to symbol in our inequality, so we're going to connect this with a solid line. It wants to shade everything greater than or equal to, so greater than has to be above our line. So I'm going to shade everything above the line we drew. Y is less than -4, so remember -4 is my y-intercept. That's a horizontal line. It's not equal to, so we'll use the dash. It wants everything less than it, so we're going to shade everything below. This can be a tricky graph because a lot of people would feel like it doesn't have any solutions, but just know way out here, if we were to extend that graph, we would be able to find an area where both the black line is shaded above and that purple line is shaded below. Let us know if you have any questions. Please come in for ACT Lab or ask us in class.